But then, of course, there are all these small areas which are completely underfunded, where a very small amount of money could lead to an enormous increase in knowledge. For example, if some donor decided that, okay, we're actually going to take serious about modeling nanotechnology immune system risk, that would have an enormous effect. If somebody would decide, oh, okay, let's take artificial intelligence risk seriously, or self-replicating machines, the total amount of effort that needs to go into that might not be enormously big, but I think you could fill it up quite quickly. Yeah.
Sorry, Anders. So you've got these various scenarios like black swans and dragons and so forth. There's possibly another category. I'd be curious to see what you think about it. It's sort of like a mountain probable situation, like after Richard Dawkins. So for anyone who doesn't know, Richard Dawkins pretty much has said you'll often get fundamentalist Christians will say that evolution can't possibly have happened because the chances of the final product of evolution having appeared purely randomly are astronomically low. And then he's pointed out that, well, actually, if you break that outcome down into a process of many, many, many little steps, and at each level it's improbable, but sooner or later you get a spike, a power law type outcome, and then the system has a memory and it builds on that, and eventually what seems on balance like an incredibly unlikely event becomes pretty much inevitable. Mm-hmm. Now, I know some people, not so much lately, but some people in the past have said that things like nuclear war or even singularity scenarios could fall into that kind of category. It's pretty much, it's like the it's pretty much like taking the thermodynamic miracle kind of scenario, where the things you would expect to see happening from a thermodynamic miracle do happen in the world. They just don't happen in a single leap in the way we'd expect miracles. So, do you think that some things that are written off as unknown unknowns, they could actually be nigh inevitable because of this mechanism?
Yeah, but I think that is probably true. When you think about human history to some extent, once it really starts taking off with agriculture, I think to some extent the advanced technological civilization is inevitable. It might be very broad distribution when it occurs, because you need a number of relatively improbable steps, like getting a written language, getting somebody to discover a scientific method in the right environment and so on. But I think that is a pretty close thing to it. Sometimes you, of course, can monitor things. Hellman wrote a pretty nice paper, I think, about the risk of nuclear war, where he had kind of state machine model, where he points out that it's not like peace, nuclear war, and there is a probability of a transition. It's rather within this peace state, we have various states of escalation. So you have the Russians and Americans slightly uneasy about each other, and then you have them quarreling about a small nation, then one of them stationing some missiles there, and then you can move all the way up to something like the Cuban Missile Crisis, where suddenly the step is not that far. I think it's a pretty good model, actually. It also suggests that one way of working with this is trying to monitor this. The question is, are there unmonitorable things that are growing? Well, I'm somewhat worried about what might be going on the net, actually. It might not be that the computer viruses are evolved, but it might be that we're developing software and social institutions that might actually be having very great and not necessarily positive effects, which we really can't predict. Social networking, for example, allows any group of people now very efficiently to form a community. They might not get that much power from it, but you can get very rapid community formation and meme spread within that community. Twitter allows very rapid spreads of ideas, which in the case of the porcine flu epidemic was probably a bit of a problem, because it also spread a lot of panic reaction. To some extent, that overreaction was very helpful, because people was again reminded that, oh, flu is no laughing matter, we need to handle that. But you could imagine some kind of emergent phenomenon on Twitter actually causing massive disruptions. So it could simply be that we're developing some technologies. They all seem like a good idea at the time, and they all lead to each other, that might lead to, well, a singularity or some nasty outcome. the question is how we actually measure this. I guess one way of looking at it is when thinking about mixing stuff in a chemistry lab, one easy way of avoiding accident, well, at least one way, is try to think, well, is there a lot of energy in these different compounds? If it's low energy compounds, it's less likely that it's going to blow up than if you're starting mixing high energy compounds. Similarly, doing high energy physics, when you actually start thinking about the total energy in a particle collision, well, compared to other things, it's actually pretty small. So that kind of comparison gives you a scale of how dangerous could this possibly be. The problem is, of course, that self-reinforcing processes, like an artificial intelligence making itself smarter, or something that is self-replicating like a living organism, can actually take something that looks like pretty innocuous and scale up. So I would look for kind of energy in a wide sense and strong feedback loops. That would be where I would be looking for these kind of mounting probable type of disasters.
Anders, do you think in general that with disasters we learn, you seem to be advocating there that you look for problems and prevent them from happening, which is definitely good in that. But do you think in general up to this point the human race has mainly learned from accidentally mixing the chemicals together and we lose a couple of members of the human race basically, and then from then on everyone gets the sheet telling you not to do that?
Oh yes, I've been having great fun reading a blog where a chemist writes about stuff I want to touch. There's some of the stuff is simply amazing. Nickel carbonate. Oh, what a horrible substance! And he's talking very warmly about some German researchers who do this amazingly dangerous experiment, where we kind of point out that you needed to have your armored suit on, and we couldn't make a spectrogram of the cesium salt because it exploded before reaching the equipment. In general, of course, we're very bad at predicting disasters, and we tend to react to them. To some extent, this is the problem of all these kind of power law distributed things. They're very rare, so we don't have much experience until they happen. And even after they happen, we tend to forget the lessons because it might be 1 or 2 generations before the next one occurs again. If you think about it in a commercial setting, how much should you spend on the security? Well, you can spend a sizable amount, and then all the bean counters are going to point out that it's pretty expensive and nothing has happened. So there is an economic incentive to remove that, and all that redundancy, you can also remove that. And Sweden made apparently a lot of good money from selling all that oil stored for possible future crises in big underground cisterns a few years back, which made a lot of sense at the time. But in the case of a sudden electromagnetic pulse wiping out worldwide communication, we're not going to be very happy about that decision. So it might be a good thing to have a suitable background level of disasters, which is problematic because some disasters might have a distribution that you actually don't want to have any of them. You don't want a background level of nuclear wars. If we had, well, the survivors would probably develop some good strategies, but not the most efficient one.
One of the other things, the kind of LHC safe, unsafe, because I don't know, I see it more as a fuzzy thing. You know, it is unsafe. It's killed a couple of workers who fell down a shaft or whatever during the eruption and broke their necks and that. And the other end, I think what we're arguing about is that it isn't going to wipe the planet out basically suddenly. But it's, I don't know, the arguments for that seem to be the opposite way round. They started from the premise the LHC is safe and then justified it to stop everyone complaining.
Which is quite natural, of course, from a human perspective. And again, from a physicist's perspective, it's a bit like mixing these low energy compounds together. It's pretty obvious that it's not going to do anything dangerous. Which is not necessarily true, of course, because again, mixing low energy compounds together, you must still get something very toxic out of it.
Well, there was an example at the Oxford conference about the first time the nuclear fusion took place, and there was much more energy released than had been expected.
The Castle Bravo. It's even more embarrassing. I think it was the second or third time they did a nuclear fusion bomb. And this time they tried using lithium-6, I think it was, and they didn't calculate the yield from lithium-7, which was mixed in, and whoops, they got 20 megaton extra. That's the most energetic mistake of human history.
And some people died as a result.
Yeah. And it's a pretty interesting example because this was really a kind of science mistake. They understood the physics, they even could have done the